Okay, so Betelgeuse is a red supergiant star. If you plopped it down where our Sun is now, it would stretch all the way out to Jupiter's orbit. Seriously huge. And it's super unstable, probably going to blow up. It also spits out a ton of radio energy, way more than 1 billion suns. When we think about stars, we usually think of little pinpricks up in the sky. But stars are way bigger than that. Betelgeuse is a lot bigger than our Sun. Scientists have been scratching their heads about this star for ages, but lately, things have been even weirder, making them extra concerned. This video will tell you all about Betelgeuse, its possible explosion, as predicted by the James Webb Space Telescope, and how that whole thing might shake up the universe and our lives here. Physicist Michio Kaku calls Betelgeuse a massive marvel. Some Greek dude, Antonius, spotted it way back when. It's so big, you can see it at night from Earth, especially in the winter. If you're into space stuff, you've likely seen it. It's that reddish-orange star on Orion's upper left shoulder. So yeah, it's ancient and super bright. But here's the thing, Betelgeuse's brightness isn't constant, it changes, which is just one interesting thing about it. Most stars we see are super far away. The closest one is 4.2 light-years away. A light-year is how far light travels in a year. Light zips along at 186,000 miles per second. That's billions of miles. So, 4.2 light-years? A seriously long way. And Betelgeuse? It's about 600 light-years away. Even if we could travel at light speed, it would still take us 600 years to reach it. Our rockets can't even come close to that speed. But it still shines brightly in our sky. It's so bright because it's huge and gives off tons of light. Its radius is about 1,000 times bigger than the Sun's. When you look at it through a telescope, it looks like a disk, not a point of light like other stars. This is likely because of reactions happening in its outer atmosphere. As for mass, Betelgeuse is about 12 to 19 times the mass of our Sun. Scientists can't nail down the exact number because there aren't any planets or other stuff orbiting it to compare it to, and we can't exactly weigh it from here. Betelgeuse's brightness changes between magnitude +0 and +1.6. Basically, it's way brighter than our Sun. That's why they call it a red giant. But its brightness isn't steady, it pulsates. When it gets bigger, it gets brighter. When it shrinks, it dims. This can last from a few months to way longer. Another weird thing about Betelgeuse is that it has dark magnetic spots all over it. The magnetic field there is super strong. But these spots mess with the flow of hot gas to the star's surface, making those areas cooler. Betelgeuse has way more of these spots than our Sun, which helps explain why it's cooler even though it's huge and bright. The spots on Betelgeuse can be twice as big as Earth. It also has a magnetic field that's 10 times stronger than the Sun's. That's why, through a telescope, the gases on its outer layer look like circles or curves. Betelgeuse's surface temperature is around 3,500 Kelvin. That's pretty low, which makes it give off less energy and gives it that reddish color. It's a red star now, but it wasn't always. Around 10 million years ago, it was yellowish, like our Sun. Then it turned orange-red, and about 100,000 years ago, it started turning into the red star we see today. Scientists think that means it's getting old. Betelgeuse makes about 100,000 times more energy than the Sun. It would be a serious rival if it weren't so far away. It's pretty wild that we can still see it at night, even though it's 600 light-years away. Our Sun is only 8 light-minutes from Earth, which is why it seems so strong. If Betelgeuse were closer, it would be visible during the day too. But if it replaced the Sun, it would either swallow up or push away Earth and the inner planets because it's so massive. And even if it were the same size as the Sun, it would still give off more radiation. So, yeah, Betelgeuse is a huge star in the Orion constellation, about 600 light-years away. Its size is what makes it stand out. It's way bigger than our Sun and would easily fill the orbit of Jupiter if it were in our Sun's place. That massive size means it looks like a disk through telescopes, not just a point of light. Even though it's big, it's not the most massive star out there. Its mass is about 12 to 19 times the Sun's. It's tricky to measure the exact mass because it doesn't have any stars or planets orbiting it to give us a reference point. Still, it's a seriously big star. Its brightness is another thing. It's always changing, going from magnitude 0 to plus 1.6. A magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be 1,000 times brighter than our Sun. This is because it's pulsing, expanding and shrinking because of stuff happening inside. These pulses can last for months, making it a dynamic star to watch. Betelgeuse's surface temperature is relatively cool for such a big star, around 3,500 Kelvin. This gives it the red color that's typical of red giant stars that are nearing the end of their lives. Like other red giants, Betelgeuse is getting old. It's used up the hydrogen fuel in its core and has started fusing heavier elements. This makes energy and causes the star to expand. Its atmosphere is full of interesting stuff. There are dark magnetic spots where the magnetic field is stronger. These spots block heat, making the surface cooler in those areas. Even with these cooler spots, Betelgeuse is still huge, but it will eventually explode in a supernova. Betelgeuse is huge and nearing the end of its life. When it runs out of fuel, it will start fusing heavier elements, like helium and carbon. This will make it expand even more, possibly becoming one of the biggest stars we can see. Then, it will go out with a bang. A supernova, the death of a massive star. A supernova is so powerful it can briefly outshine an entire galaxy. The explosion could send shock waves through space. Scientists are watching closely, hoping to learn more about the future of stars and the universe. As Betelgeuse gets closer to the end, astronomers are keeping a close eye on it. Eventually, it will go supernova, blasting its outer layers into space, leaving behind a dense core. That core could become a neutron star or a black hole, depending on how massive it is. A supernova is the last hurrah in a star's life. Betelgeuse's supernova could be visible from Earth without a telescope because it's so bright and relatively close. The explosion will release a huge amount of energy, creating heavy elements like iron and nickel, which are needed to make planets. These elements will spread out, enriching space and helping to form future stars and planets. Scientists have seen weird changes in Betelgeuse's brightness lately, leading some to think it might go supernova soon, although it's hard to say exactly when it will happen. Some think it could be within the next 100,000 years, a blink of an eye in cosmic time. The James Webb Space Telescope, JWST, is helping us learn more about what is going on. Its infrared capabilities let scientists study the star's outer layers and magnetic fields like never before. JWST has verified that the star is changing, including its weird brightness and potential instability. These observations give us clues about what happens before a star dies, helping us understand how stars evolve.